Galaxies that defy conventional norms are stretching across the cosmos like surreal surfboards, and interstellar pool noodles mean literally. It might sound like an extraterrestrial daydream, but it is an astonishing reality. What if our understanding of galaxies is about to take a mind-bending leap into the extraordinary? What unseen forces shape these unconventional galaxies, and how do they defy the norms we thought were written in the stars? Join us on a journey beyond the ordinary as we dive into the unknown, making us rethink everything we thought we knew about space. Are you ready to venture into the uncharted territories of our universe? Then stick with us until the end of the video. It's a revelation that shatters the very foundations of our cosmic understanding. According to a study led by Viraj Punda, a NASA Hubble Fellow at Columbia University, between 50% to 80% of observed galaxies from when the universe was between 600 million to 6 billion years old were not your typical neatly rounded structures. No, they were flat and stretched out, defying our expectations and rewriting the cosmic rulebook. It's a mind-boggling thought, isn't it? Howen Zhang, a co-author of the study and a PhD candidate at the University of Arizona, suggests that the James Webb Space Telescope, JWST, has provided new evidence allowing scientists to estimate the mass and potential shape of our very own galactic home billions of years ago. But the surprises don't end there. The study reveals that these peculiarly shaped galaxies of the past were significantly less massive than the spirals and ellipticals we're familiar with today. Karthik A., another co-author and NASA Hubble Fellow at Columbia University, emphasizes the importance of identifying these early galactic categories, opening up new avenues for understanding the mysterious ways in which galaxies form and evolve. Now armed with its advanced capabilities in infrared imaging, JWST is capturing these distant galaxies with unprecedented detail. Its high-resolution images and sensitivity allow scientists to delve into the three-dimensional geometries of these ancient cosmic structures, building upon the groundwork laid by the iconic Hubble Space Telescope. But there's still much we don't know. The research team acknowledges the need for a larger sample size from JWST to refine our understanding of the properties and locations of these distant galaxies. Now take a moment to consider the implications. What if we could witness our own Milky Way in its ancient days? Would it have looked more like a surfboard than the familiar spiral we recognize today? JWST's first year of observations has been nothing short of a roller coaster, turning up thousands of distant galaxies dating back to the early universe. They are bigger, brighter, and more mature than astronomers had ever expected. It seemed too implausible that their light had shone across the universe from about 13.3 billion years ago, less than 400 million years into the universe's existence. But then JWST stepped in, aimed its massive mirror, and validated those claims. The galaxy's light is indeed ancient, dating back to just 390 million years after the Big Bang. And it's not alone. The JWST has unveiled a multitude of distant galaxies, each with its own story to tell, brighter, more massive, and more mature. Let me introduce the Universe Breakers, a set of galaxies that defy not only the norms of galaxy formation but the very theoretical foundations of our universe. 6 celestial anomalies spotted with seers have grown to such colossal proportions in the mere blink of cosmic time that they've earned this nickname from astronomer Nelson. With photometric redshifts between S and N indicating a cosmic upbringing within the first 800 million years, these celestial giants boast stellar masses rivaling or surpassing our Milky Way at a staggering 60 billion solar masses. Mike Boylan-Colchin, an astrophysicist from the University of Texas at Austin, throws a cosmic spanner into the works. The ordinary matter available back then, the cosmic atoms at the disposal of budding galaxies, would have had to transform entirely into stars to birth these universe breakers. Recent data from the JWST challenges the very fabric of our understanding. A paper fresh off the press reveals that objects older than the universe itself have been spotted. Yes, you heard that right, galaxies that predate our known universe. Scientists are cautious, awaiting peer review to confirm these mind-bending discoveries, but let's dive into what we know so far. The JWST has shattered records, surpassing the Hubble Telescope's findings. The most distant galaxy ever observed, GZS-13, existed a mere 325 million years after the Big Bang, putting it at a mind-boggling 33 billion light-years from Earth thanks to the universe's expansion. Among these distant galaxies, one turned out to be an imposter, a dust cloud playing cosmic hide and seek, fooling our observations and challenging the very tools we use to understand the universe. The JWST may have glimpsed galaxies even closer to the Big Bang, galaxies that throw our established cosmological model into disarray. And just when you thought the roller coaster was slowing down, the JWST unveiled Our conventional model predicted a certain order in the evolution of early galaxies, suggesting that as we peer deeper into the past, galaxies should become less organized and smaller. Galaxies like Sears 212, resembling our Milky Way, emerged just a few million years after the Big Bang. This defies the expected timeline for the formation of spiral galaxies, challenging our understanding of galactic evolution. Shortly after the Big Bang, when the universe was in its infancy, just 500 to 700 million years old, our expectations were clear. We anticipated the birth of young small galaxies emerging like cosmic infants from the dark ages. But the images captured by Webb's near-infrared camera during its early observation campaign unveiled a cosmic anomaly. Giant mature galaxies hefty enough to rival our own Milky Way appear as tiny reddish dots in the telescope's field of view. It's like finding a grizzled elder in a nursery filled with newborns. Nobody saw this coming. These galaxies, massive and full of mature red stars, defy the expected narrative of the early universe. We had specific expectations for young and small galaxies that live in the early universe. They are young and small. This was astounding. We're finding galaxy candidates as massive as our own galaxy when the universe was only 3% of its current age. The Hubble Space Telescope, Webb's predecessor, painted a different picture. Previous observations suggested a universe filled with small blue baby galaxies in its infancy. Yet here we are faced with a stark contrast of mature cosmic behemoths. The images that brought this cosmic mystery to light were captured by Webb's near-infrared camera as part of the Cosmic Evolution Early Release Science program. But the story doesn't end here, it merely reaches a cliffhanger. Astronomers plan to turn Webb's mirror once again toward these enigmatic galaxies, this time armed with a different tool-light spectra. The suspense is palpable. The answers may rewrite the very rules of cosmic evolution. The Webb Telescope has given us a glimpse into the very early universe, and what we've discovered is nothing short of astonishing. As we stand on the precipice of discovery, one thing is becoming increasingly clear: the James Webb Space Telescope is not just confirming what we thought we knew, it's tearing down old paradigms and rebuilding our understanding of the cosmos from the ground up. Every new image, every data point, every spectral analysis paints a picture far more complex than we ever imagined. Galaxies that should not exist in their present state, distant cosmic structures that defy our theoretical models, and the potential detection of objects older than our universe itself. Each revelation is a piece of a puzzle that we are only beginning to grasp. Scientists are now faced with the monumental task of reconciling these discoveries with our existing models of cosmology. Are we missing a key ingredient in the formation of galaxies? Could there be unknown physics at play, perhaps an undiscovered force or a new interaction between dark matter and normal matter? Or more radically, do these findings hint at a deeper flaw in our understanding of the universe's origins? If galaxies this massive formed so early, could it mean that the Big Bang model needs revision? Some theorists are even exploring the possibility of an earlier cosmic event, a pre-Big Bang scenario that could explain the presence of these colossal galactic structures. The JWST is still in its infancy, and its mission has only just begun. With years of observations ahead, astronomers are preparing for an era of unprecedented discovery. Upcoming deep field surveys will probe even further into the early universe, capturing galaxies that may push the boundaries of what we believe to be possible. And beyond galaxies, there are still mysteries to unravel. What will JWST reveal about the atmospheres of exoplanets? Could we detect biosignatures, signs of life, on distant worlds? How will its observations of black holes and dark matter influence our theories of gravity and quantum physics? We are witnessing the dawn of a new cosmic era, one where our understanding of space-time and existence itself may be rewritten. JWST has already proven that the universe is far stranger and more complex than we ever imagined. What we have seen so far may be nothing compared to what awaits us in the depths of the universe. With each new discovery, we take one step closer to unraveling the grandest mysteries of all: our origins, our place in the cosmos, and perhaps even the ultimate fate of the universe itself.